So here we have password which is of 6 bits and a salt value which is of 12 bits. Put together we get a crypt, and we put that crypt into the password file. So salt values can be like, for example, you give a password, some additional values will be added to your password and it will be put up into the password file. So it becomes difficult for the hackers to actually guess what the password is. So this is the salt values, randomly generated value which will be put along with this particular password, so that it becomes difficult for the hackers. So the first one is actually, first step is we have loaded the new password into the password file. Next is, like, if you want to do the verification, how will you do the verification? So we have the encrypted password with our password file. So when a user enters the password, so that password along with the salt value will be matched, and it will be compared, it will be matched or compared to see whether it is of the same kind. So if it is same, the user will be allowed to access the system. And this is the next one. So you can use the salt along with the password, which is used as a uses with a slow hash function, and it is loaded into the hash code column of the password file. This is another method. So here you use a slow hash function, and again the comparison is the same one. So if the user enters the password, it should be added to the salt value, and it should be put into the slow hash function, and that will be compared to the hash password. If both are the same, you can allow the access to the user. So salt value has three purposes. So it prevents the duplicate passwords from being visible in the password file. So that's the primary purpose of using the salt. So it prevents the duplicate passwords from being visible in the password file, and also it increases the difficulty of offline dictionary attacks, as we discussed earlier. So dictionary attacks are like the words that are actually known, so with possible words that can be used as a password, so that can be avoided. And also it is also nearly impossible to tell if a person with a password on multiple systems has used the same password. So these are the primary purposes of using the salt value. So next we are going to see the improved UNIX implementations. So here we have the other stronger hash or the salt variants. So many systems use what is called as the MD5. So it is nothing but the message digest, which is a algorithm with a 48-bit salt, and the password length is unlimited here. It is also hashed with 100 times inner loop. It also produces a 128-bit hash. And this OpenBSD uses Blowfish block cipher based hash algorithm called bscript, which again uses a 128-bit salt to create a 192-bit hash value. So these two, like MD5 and the Blowfish block cipher, are important, which are being used in the UNIX platform. So how do the passwords get cracked? So we have discussed earlier. So first, the primary one is the dictionary attack. A large dictionary of possible words are saved up and they are tried, and all possible, even the salt values, are being tried out. So you do not think that only the passwords might be one which is prone to attack. Even the salt values can be guessed, and it is used for attacking So it's always dangerous. We cannot say that every time your system is being uh, uh, is safe, right? So we face a situation where sometimes even if you add salt values, it becomes difficult to uh, protect your system. So you try each and every word, then obvious variants in the which are variants in the large dictionary against hash in the parser file. So we try every possible word which will hack your password. Next is the rainbow table attacks. So it's a trade of space for time. So here what we do is we pre-compute the tables of hash values for all the sorts. Here we get a mammoth table of hash values. So here, like example given here, 1.4 GB table cracks about 99.9 of the alphanumeric Windows passwords in 13.8 seconds. So we already know that Windows is having a weaker password protection. So it's always safe if you use a combination of uh, pa passwords, like a combination of characters, digits, special characters, etc. So if it is not like that, it's very easy for the hacker to hack your password. And also it's not feasible if the larger salt values are being used. So how can you use your passwords? How do you choose your passwords? So a user may pick short passwords, right? So that is a primary mistake we do while choosing the passwords. So users may pick short passwords. So example here, 3% where 3 characters are less, right? So it is easily guessed. So 3% of the users, like, they use 3 characters or less. So it's highly shocking to know that only 3 characters in a password is highly prone to attack. It's very easily guessable. So nowadays systems are going for like minimum 6 characters or 8 characters, or maybe even 12 characters or 10 characters. So it is difficult for the users to or the hackers to guess. And system can reject these kind of choices that are too short, as I told you earlier. So here passwords should have a specific length, um, which is not guessable, and users may pick guessable password. It's another way of, like, the hacker to get into your system, so you can guess the password. So the hackers use the list of likely passwords. Example, like they have done a study where the 14,000 encrypted passwords were guessed nearly 1/4 of them was nearly guessed very easily. So it would take like about 1 hour on the fastest systems to compute all the variants, and only one break is required. So it's highly shocking to know all these information. So this is the table um, of passwords that was cracked from a sample set of 13,797 accounts. So you have type of password, the search size, the number of matches, and the percentage of passwords that are matched, and also the cost or the benefit ratio. So you can go to this table, so you can learn how the passwords are actually being guessed. And next we are going to see what is the password file access control. So here you can actually block the offline guessing attacks by denying the access to the encrypted passwords, and make available only to the privileged users. And they often use a separate shadow password file. So here, first thing is you're going to block all the offline guessing attacks by denying the access to encrypted password. So that's the first and primary one, and you also give preference only to the privileged users, not all. But still you have vulnerabilities. If you follow this, you have vulnerabilities like they can exploit the OS bug, accident with the permissions making it more readable, right? So accidentally you allow a password, like uh, uh, it becomes more readable, right? And also the users with the same passwords on systems are possible, like if you face that problem. And also access from unprotected backup media, and sniff passwords in unprotected network traffic. So sniffing is like you search for the passwords, you keep searching in an unprotected network.